Let's also look at the second part of my title. There was innovation and then there was massive timber products. Yes, I am standing here today with a Wesbeam hat on, but previously I stood here in front of audiences just like this with a WoodSolutions hat. So I'm more than happy to talk about the range of innovative, massive timber products and how they fit into the matrix together, because I really do believe that there isn't one material that solves all the problems. Let's start with glulam. Glulam, or glue laminated timber, first became known, or was first documented to be used in 1842. Now that term, first extant use, is indicating that in 1842 someone glue laminated some beams and they put it up in a roof, and that building is still here today. It's a church in the UK. So in 1842 they started glue laminating beams together. First patent, 1872. First large span hall that I'm aware of, 1925 in Stockholm, at Stockholm Central Station, still in place today. And the big glulam beams that are supporting the main hall there is spanning 32 metres. That's a combination of a milk-based glue and steel plates that wrap it around and support it. And that is still doing its job here and today. And to I guess, bring a local context to it, our largest free-spanning glue laminated structure here in Australia is the Sydney Olympic Dome, I believe. Gregory, Yep, 99 metres in Sydney. And if you ever get the chance to go to Homebush, and you go and poke around the building, go and have a look at that structure. It is just gorgeous. This dome-shaped, glue laminated beam structure, and it's just spectacular. Right, the new boy on the block. No, not quite. LVL. LVL, which is laminated veneer lumber that Wesbeam manufacture in Perth. Now, that was developed to try and find an innovative way to use small section logs. So up until that point, they had been getting logs and sawing them up into studs and beams and elements like that. They realised that they could peel those logs and get a veneer off it and stick those together. In the 1980s, it was brought into the North American market as part of this ex-novation process. The first Australian factory came into South Australia in the 1990s. In 2004, Wesbeam set up in Western Australia specifically to make LVL to replace as a replacement for the F-17 hardwood industry in Class 1 residential buildings. 2017, Wesbeam started the Tall Timber Building Systems division. They headhunted me out of WoodSolutions to head that up, and the purpose being was because they understood that there is a new opportunity emerging and LVL wanted to be part of that discussion. Wesbeam wanted to be part of that discussion. Now the true new kid on the block, CLT. CLT, of course, is the term that's been dominating everybody's minds in the space of engineered timber for the last 5 or 6 years in Australia. Similarly with LVL, it was finding a way to use small section timber sections, scantling effectively, from low-grade logs and find a value-added product for it. In the 2000s, we started to see its more widespread use in Europe. First used, I believe, in certainly a large-scale format, 2011 in the Forte building. Is that correct? Is that when that went up? Just down the road. And of course, the signature thing for Australia, I think the thing that really makes a big difference is this year, XLAM established their factory in Wodonga. They're going to be putting out 80,000 plus cubes of CLT every year. From my perspective, whether it be my architect's hat on, whether it be my academic in prefabricated timber, or even with my Wesbeam hat on, I think bringing XLAM into this market is the most fantastic thing, because it has created a domestic supply chain that the market can start to leverage off, in addition to the more established European markets. Okay, so the reason I've got this little pop-up on this slide is that because it's all about finding the right application for each of these materials. CLT is not the answer to everything. LVL is not the answer to everything, and neither is glulam. It's about finding the right application in the right location, and I will extend that even beyond mass timber into steel and concrete. I think we heard some fantastic examples, and certainly from Greg's commentary, about how you can combine steel with the plates into the connections of timber, concrete to make floor panels with timber, concrete working in compression, timber working in tension, the two materials working together. And there's no reason why we can't continue to explore those. So that's mass timber. So we've covered off on innovation, where it goes through to ex-novation into the market as a normalised and regularised product, and some of the materials themselves. The other thing that's worthwhile acknowledging is that the NCC now recognises mass timber. This is the current definition for mass timber. It's any timber element greater than 75 millimetres in multiple directions that is formed chemically bonded. It could be CLT, it could be LVL, it could be glue laminated timber. That's the current definition in the NCC. Those of you who are following the development of the NCC in the 1st of May 2019, you'll see that they've actually changed the definition. They've simplified it and broadened it. They've kept the 75 millimetre, and I'll talk about that in a second, but now they've taken away the need to have it chemically bonded. It could be just sawn timber, it could be nail laminated, it could be bracketed, it could be dowel laminated. There's a whole range of different ways that you can hold these mass sections together. And I think this is a really important next step in the process of us understanding what mass timber is. Why is this important in the code? Because the code acknowledges that mass timber brings a particular benefit to a project. Just excuse me for a moment. Specifically dealing with fire. Now, think of it this way. You've all been camping, I'm sure. You've all lit a little fire to put your billy on. Oops, I'll just go back. Didn't mean to jump to that. And you started off with small sticks, and the small sticks burn quite quickly. So you very quickly need to start loading it with bigger sections. The bigger sections sit there and they char away and they allow you to boil your billy. And of course, that takes a long time to burn through. Well, these definitions of mass timber are acknowledging that when you get large sections of timber and they get in a fire situation, they perform differently to small sections. And I won't go into it because that's not what my presentation is now, but that there are a range of concessions that allow you to access in the NCC as part of the deemed to satisfy solutions that recognise that. Okay, so innovation and mass timber products, a little bit more about my journey. Following doing the WoodSolutions workshop with Gregory back in 2007, I decided to begin my own journey, and I started a PhD into prefabricated timber, specifically looking at the innovation and the opportunities that had emerged in Scandinavia. And then I looked at how could we apply those in the Australian context. Well, I didn't want it to be a theoretical PhD, and so I thought, well, how did they start? They started with a couple of guys in a back shed with pieces of timber, and they thought, how can we fix these together? So I developed a nail laminated mass timber panel. It was simply to do an applied application of what I'd been learning in the Australian context. I worked with a couple of Australian carpenters. I worked with West Pine, the softwood sawmill in Western Australia, and developed this nail laminated solution. We had it engineered in a variety of different formats, up to about 5 or 6 story building to take the loads to that structure. So that was something that I thought I needed to do to understand what we might be able to do in our context. This is back in the 2008-2009 period. West Pine very kindly allowed me not only to work on some prototyping, but to build a small design and have a small office building built using this nail laminated technology. Now, this obviously was not a 5 or 6 story building, but it was a proof of concept to say, hey, you can make a mass timber product with a fairly low-tech approach, don't need the big investment, and it can perform according to the specification. So these are some of the images from that project, and I received a Judges Innovation Award. I was a finalist, I should say, as a Judges Innovation Award 2014 Timber Design Awards. All right, stepping on a little bit to my time in Tasmania, the NRAS Inveresk student accommodation building was a building that was developed with, you might say, early contractor involvement with a number of players in Tasmania to build this 4-story building. It was on 1 level of concrete podium with 3 levels of timber on top of that. I used this project as a case study to present at a World Conference in Timber Engineering in 2016 and wrote a paper with Greg's assistance talking about innovation, and one of the key points to take out of that paper was that if innovation is about risk, and it's not only just about real risk, but about perceived risk. And if it is determined that perceived risk of innovation is higher than the identifiable benefits at any point in the process, generally it won't go ahead, it will be abandoned. Now, why am I bringing that up? Because I think it's really important to understand the whole pathway of innovation from conception to realisation to application. And there's a whole series of risks involved in that. I'm going to talk a little bit about where my journey is currently in a moment, but in that process, I suppose it's about going into it with your eyes wide open. And if I can draw back into my PhD, one of the things that I learnt from studying the Swedish model was that innovators there in engineered timber products were very quickly and easily drawn away to this latest and greatest thing and this latest and greatest thing. And the determination was that once you've chosen your system, stick with that system, work with that system, limit your options so that you can work that through to finalisation rather than have too many options on the table. These are some of the images of the NRAS building under construction. And there's a couple of key things that allowed innovation, and I'll call it innovation, through that project to be realised into application. One is that there is an incremental process to innovation, and you must accept that, of course. Competitive tendering, and it was interesting that we heard Rob talking about competitive tendering earlier on. There will always be some accessory tolerances. That means that people are starting to add or load their prices a little bit when it's innovative because they're not familiar with it. Speaking to the early contractor ideology again, invite the tendering contractors to come in early on in the process to have input. Construct a full-scale prototype. So that encourages accurate quoting. So for this project, a full-scale prototype of one of the complete student rooms was manufactured, and these are not them, these are the ones under construction actually, but exactly the same as that. And the people tendering it were invited to then come in, look at exactly what it was they were being asked to tender on and price to that, not to a set of drawings, not to try and interpret a set of specification by itself, but literally to take that and apply it to the example that was right in front of them. And then bringing the nominated subcontractors to supply the innovative component. Now, as innovation itself can be incremental, we don't need to innovate the entire project. A lot of innovation went into this project, but not everything. So if you can see there, this is actually a combination of light frame prefabricated volumetric modules, and CLT. That image on your right is the CLT, one of the CLT floors, in this case through the connecting spaces between the modules being installed inside a steel frame. So the builder himself was familiar with steel. The design team decided to incorporate the steel and the timber to give some certainty into the contractor. As it turns out, it probably didn't do them any favours because the tolerances of the steel were set to industry standard, which was not particularly high. The tolerances to the CLT, which by the way came from XLAM, at that point New Zealand XLAM, was down to the millimetre, and they quickly found out that the two shall not meet particularly happily. And the feedback at the end of the project from the builder was, well, next time I won't worry about the steel. We didn't actually need it, as it turns out. We could have just done it all in CLT. That would have kept like with like. But that was one of the learnings from that project.